Thank you for that instruction, how to use a microphone. It's been a while. So thank you for that introduction, and thank you to the PyData Paris organizers for giving me the opportunity to come here and share my love-hate relationship with the London Underground. If you've ever commuted on any metro system in a big city, you know what I'm talking about. You know the feeling when you start feeling like a sardine in a can and people just keep squeezing and squeezing. So yeah, that's what I'm talking about. Okay. So, right, the talk's going to be about, it's going to be a story of how I came to London, started commuting, and started asking, how can I use Python to study this system? So before I dive into the talk, I'd like to say something about my background. So I graduated in 2014 from Bryn Mawr College. You've probably never heard about it. It's a small university just outside Philadelphia. You should definitely visit and eat some Philly steak. I can definitely recommend. After that, I went to the University of Edinburgh for a year to study informatics, and then last August, I moved to London to work as a QA engineer at Kaplan Systems. So by day, unfortunately, I don't get to do any Python, mostly Java, but then at PyLadies London and Women in Data, there's certainly plenty of Python. I'm also a member of PyData, but Ian already gave a pretty good talk about that, so I'm not going to spend any more time. And if you're ever in London and there is a PyLadies or a Women in Data meetup, you're all welcome to come. Okay. So if you don't take anything else away from this talk, I'd just like to inspire you to take some Python tools and just start looking at interesting problems in your environment. So they're basically everywhere, and Python certainly gives you the tools to analyze them, but you have to ask the questions. Right. So what is the motivation for this talk, for this love-hate story? This love-hate story starts in August 2014, and exactly on August 15th, which was the last day of the academic year for my course at Edinburgh. So on that very same day, I basically packed my suitcase and took the first train from Edinburgh to London. And I rented a flat, where's the pointer, in Marylebone, and my job was located at Liverpool Street Station. So every day, I would take the tube from either Edgware Road, Marylebone, or Baker Street and commute all the way to Liverpool Street. Right. So on most days, sorry about that, on most days, I took the tube from Edgware Road just because I was lazy and I didn't want to walk, and Edgware Road was the closest one. And as I began commuting more and more often, I noticed certain periodic patterns in the congestion of the station. So I always took the train at 8 a.m. and on some days it kind of looked like this. So it was fine, and if you were lucky, you might even be able to get a seat on the train. But then on other days, it was like this. So you'd have to basically squeeze in as hard as you could to get on the train. And so I started wondering, why was it the case that on some days at 8 a.m., there was pretty much no one at the station, and then on other days, it was so hard to fit into a train that you started feeling bad for the sardines in a can. Right, and I started noticing some patterns in this periodicity of congestion at the station. So for example, if one of the other lines was suspended, it was more likely that Edgware Road would be congested. What was even more interesting is that the malfunction didn't necessarily have to happen on a line that was passing through Edgware Road. It could have happened on any one of the distant stations. So for example, I remember one morning when there was a signal failure at Moorgate, and there were so many people on Edgware Road that I couldn't fit onto a platform. I literally had to sit on the steps and wait for the traffic to clear off. So this led to an interesting observation, which was basically that there are some stations in the London Underground that are more important for the overall functioning of the network than other stations. And basically, from this observation, I defined two questions that I want to answer during this talk, or at least attempt to answer. So the first one is, what are the most important stations in the London Underground network? And I'm putting important in quotations because obviously how you define an important station will depend a lot on the context and the problem you're answering, and I'll come back to that later. And then the second question is, how does suspending one of these important stations affect the rest of the network? Right, So let's start throwing some Python at the data. But first of all, we have to get the data. So we have this. Everyone who commutes in London basically has a physical map of the London Underground. And we want to take this and somehow translate it into a graph, or a graph object that we can then analyze using Python, or something like this, for example. So there's the problem of data collection. And I'm really lazy, so I spent probably a few months just searching the internet and hoping that someone else had already done this work for me. Then I spent another few months trying to use some optical character recognition to basically just feed the image of the map and get a text file of the relationships between the stations. Unfortunately, yeah, that didn't work, as you might as well have guessed. So one morning I just made myself a strong cup of coffee, and I wrote down all of the 300 plus stations in a text file. So I created this text file with the station name and then all of its neighbors and the tube lines that go to those neighbors. By the way, this text file is available on GitHub, so you won't have to do that. You're welcome. Right. So now, of course, it's going to be a piece of cake to just throw some Python and get some pretty graphs. This graph doesn't actually have much data analytic value. I just like it because it's pretty. Right. So let's go back to our question one. What is the most important station in the London Underground network? And for a while, let's just take off our data analyst shoes, and let's just use our intuition to see if we can come up with an answer. So if you look at this map, and if we use our intuition of what might be the most important stations, we might start to think that maybe Baker Street, or Baker Street's right there, or Liverpool Street Station, right there, might be the most important ones. Could someone tell me the reason of why I think those two are important? Can you see anything in the map that might indicate why they might be important to the overall functioning of the network? Yes, that's correct. So in fact, both Baker Street and Liverpool Street Station are at the intersection of multiple different tube lines. So they're very important for people commuting from different parts of London. So yeah, that's a good answer. And let's see if we can quantify our intuition and see if the data supports it. Okay. So one way to quantify importance is to calculate something called betweenness centrality, and I'm just going to take a brief detour into graph theory, on which I am not an expert, so if there's an expert and I say something wrong, please correct me. So yeah, what is betweenness centrality? So in a graph, you have vertices and you have edges connecting these vertices. And from every vertex A to a vertex B, you can calculate the shortest path. So what betweenness centrality measures is it is the fraction of all shortest paths that pass through a vertex. So for example, the vertex in blue has a very high betweenness centrality, as you might expect, because it's sort of in the center of the graph, so it makes sense that most of the shortest paths connecting two vertices would pass through it. So given this definition, I thought that betweenness centrality was certainly an awesome metric to measure the importance of a station, because the higher the betweenness of a station, the more commuters will pass through it, and thus the more critical it will be to the overall well-being of the network. So how can we compute the betweenness of our London Underground graph? So let me just take a brief detour and introduce something called graphtool. So the one great thing about Python is that if you have a data analysis problem, it's very likely that someone else has already invented the wheel for you, or in other words, written a good library that you can use. So if you're dealing with networks, you're pretty much well covered. There's Network X, and then there's graphtool, and probably about at least 5 others that I can't remember at this point. But I used graphtool for my analysis, and I'm just going to show you a brief overview of what graphtool can do, and for the rest, I recommend that you read the documentation. It's pretty good. Right, so what can you do with graphtool? So we can at first create a graph object. That's pretty simple. We can add vertices to the graph object. We can add an edge between two vertices. We can also create property maps, which are really useful if you're doing real data analysis and you want to associate each vertex or edge with some kind of property. So for example, for me, it was very important to be able to associate a vertex with a station name. And you can do that by just calling a simple function. You can also create cool visualizations. Here is a very simple visualization, and here is a super cool visualization. Yeah, that's a price network, and I think that's really pretty too. Right. And last but not least, you can also filter vertices and edges. And this is quite helpful if you're doing data analysis and you, for some reason, want to exclude a vertex or an edge, but you don't actually want to remove it from a graph. So basically, graphtool's filters allow you to mask a vertex temporarily, or mask an edge temporarily, and then add it back when you need it. And this was actually quite an important part for me because, as you know, the second question of my talk asks what happens when one of the stations in the London Underground is suspended. And so I used this feature heavily in that part of the analysis. Okay, and here's the pretty picture again. I just can't get enough of it. I apologize. Right, so let's go back to betweenness, and let's calculate it for our graph. And that's really easy. We just call the betweenness function in the graphtool centrality module. And we basically get our answer. So I've calculated the betweenness for each station and then ranked them according to size. And as you would have guessed, or as our intuition told us, Baker Street, King's Cross, St. Pancras, and Liverpool Street are the stations with the highest betweenness. So we can safely assume that they are very important to the functioning of the London Underground. So now we have our answer for question 1. But let's take this analysis just one step further and look at question 2. So question 2 asks, how do problems on one of these important stations affect the rest of the underground network? And for this problem, I thought it would be best to create some interactive data visualizations. And so I started using Bokeh. How many of you here have heard about Bokeh before? Okay, so a lot of people. So Bokeh is a fairly new project, and it's championed by Continuum Analytics. And it allows you to create apps and interactive visualizations in the browser using Python. So for example, this, and here's a bigger version of that, is a Bokeh graph of the London Underground, plotted by geographic coordinates and color-coded by the travel zone. And to return back to our question 2, I plotted all of the London Underground stations based on their geographic coordinates, and I color-coded them by their betweenness value. So the more intense the color of orange, the higher the betweenness. And you can clearly see the 3 stations with the highest betweenness here. So there's Baker Street right here, Liverpool Street, and King's Cross, St. Pancras. And so we can see that this obviously makes sense. So the stations that are closer to central London, located right here, have a highest betweenness because a lot of tube lines pass through them. And then the stations on the outskirts of London have a really small betweenness because no one really goes there. Okay. So how does betweenness of each station change when something happens at Baker Street? And so if we eliminate Baker Street, so let's say there's a signal failure and the train can't stop, we can see that all of a sudden this whole line gets a lot more pressure because now all of the people who would have normally traveled through Baker Street have to travel through one of these lines. And Bokeh actually allows us to interact with this graph so that we can remove stations and see their effect on the betweenness in real time. Right. So I'm just going to show you a demo. I was going to do this live, but because of Murphy's Law, I thought it was going to fail anyway. So I'm just going to show you to you in the browser, and I apologize for the poor quality. Okay. Okay, so this is a screencast from Chrome, and it shows you the graph that we've created in Bokeh. And so Bokeh allows you to do cool things like hover over the stations, and you can see their name. So there's just a lot of hovering going on. Right, so we've located Baker Street. And now I'm going to type in Baker Street in that box. And when I hit enter, Bokeh is going to, or actually graphtool, is going to mask Baker Street and recalculate the betweenness for all the points. So you can see that now we saw that the betweenness for that whole line changes. But Bokeh can also do a lot more than this. So in fact, we can actually build real-time simulations by using something called the Bokeh server, which comes pre-built with Bokeh. And so we can basically calculate data on the back end and then stream it to the front end to create simulations that look like they're happening in real time. So I wanted to try out this concept with the London Tube. And I created a simple Bokeh simulation where each station is assigned a random number of commuters, and each of these commuters is assigned a random destination. So at each step of the simulation, a commuter travels from one station to another. And by using Bokeh, we can actually see in real time how the number of people at each station changes. So once again, I apologize, but because of Murphy's Law, this is a screencast. Okay. So here we have the same map that you just saw. And on the back end, we're basically calculating the number of commuters at each station. And you can see that the graph is evolving. So the stations here with the red and orange colors are the stations with the highest betweenness. And you can also see that basically at each stage of the simulation, they contain the largest number of commuters. So let me pause that. Okay. So basically, just to summarize what I've said, at the beginning, we set off to answer two basic questions about the London Underground. What are the most important stations? And we used something called graphtool to compute the betweenness, and we determined that the three most important stations were Baker Street, King's Cross, St. Pancras, and Liverpool Street. And then the second question was, how does suspending one of these important stations affect the rest of the network? And we successfully used Bokeh to create interactive graphics to show that removing a very important station, such as Baker Street, can put more pressure on other stations in the tube. So thank you very much, and all questions, comments, negative, positive criticisms are very welcome, and if you don't want to say them here, you can certainly email me.